Hi, it's Liz Nedden. Let's have a look at some linear sequences. So we're going to start by looking at finding the difference. So when we've got an arithmetic or linear sequence, there's a constant amount that is being added or subtracted to find the next term. So that constant amount is called the difference, and we use the letter D to symbolize that. So generally to find it, you take a term minus its previous term, and that difference between them is your D. So let's have a look at some examples here. So we've got this pattern here, and we can see from 5 to 9, I'm adding 4. Add another 4 to 13, add another 4 to 17. So that is the difference that we're referring to. If I'm going to do it formally using my equation, I can say the difference D equals my second term minus the first term. So in that case I would do 9 take away 5, which is 4. This example here, the difference now, I'm subtracting 10 between each term. So if I take our second term and subtract our first term from that, so the second term is 7 minus the first term is 17, that gives us a difference of negative 10. Now we want to put that together to find the entire equation of the sequence. So we've got a general rule. The term t is equal to the difference times n, which is the pattern number or term number, plus a constant. So t is the term, d is the constant difference, n is the term number, and c, that's what we call term 0, or the value of pattern 0, or our constant. So here's our example. So we've got a pattern 10, 14, 18, 22. I'm going to turn that information into a table. So the first term, term number 1, has a value of 10. The second term number n has a value of 14, and so on. So we've got our general equation, t equals d times n plus c. So this is what we need to find. So we're going to start by looking for the difference. So if we think about what's the difference between each of the values, well, we're adding on 4 each time. So my difference, if I do the second term minus the first term, 14 minus 10, that gives me a difference of 4. So in our equation, t equals d times n plus c, what we want to do now is we can replace the d with that value we've just found of the difference of 4. So that means we've got a partial working now, where we've found what that difference d is. Now we need to finish the equation and find the value of c. So we start with that equation, and what we're going to do then is we know that the term number, first term, has a value of 10 and a value of 1. So if we substitute that into the equation, we get 10 equals 4 times 1 plus c. So I can simplify that. 4 times 1 is 4. And then I move the 4 to the other side of the equation, and it becomes minus 4. And 10 take away 4 is 6. Now if I found the same value by taking term pattern number 1 and subtract 4 from that, so 10 take away 4 would also give me that value of 6. So that is our constant c. So that gives us our final equation here, t equals 4n plus 6. So now I can take any value of n and substitute into the equation and find the value of the term. Let's have a look at a different pattern. So here's our pattern here, 5, 8, 11, 14. So I'm going to put it into a table. We're going to start then with our general equation, t equals d times n plus c. And we want to find that difference. So how much are we adding on each time? So in this case we're adding on 3 each time, or I can do the second term minus the first term, 8 minus 5, which is 3. So then in my equation I'm going to replace that value of d with the number 3. Now we want to go on and find what our constant c is. So we're going to start by saying, right, substitute 5 for the term and 1 for n. Rearrange and solve that equation, and that gives us a value of 2. Or if I took that term 1, 5 minus 3, take away that, gives me 2. That will find my constant value c as well. So then I can put both the difference and that constant into my general equation, and that gives me the final equation for this pattern. T equals 3n plus 2. Let's have a look at a third example. So 2, 0, negative 2, negative 4. So put that into a table, and we notice now that the pattern is going down. So it's decreasing. We're subtracting 2 each time. So if we take our second value minus our first value, that gives us a difference of negative 2. So we substitute negative 2 in place of d in my equation. Now we're going to find the value of the constant. So we're going to take the first term, 2, and its term number 1, substitute those into the equation, rearrange and solve, and that gives us a value of 4. And 2 plus 2, which reversing it would give me 4 as well. So there's my final equation, t equals minus 2n plus 4. Let's have a look at example 4. So put it into our table and notice what our pattern will be. So now we are adding on 2 each time. Now I could do the second term minus the first term, but I could also do the fourth term minus the third term, and it would give me the same value. 2 minus 0, adding on 2. So replace d with 2. Then we're going to find that constant. So we're going to start with that term is negative 4, n is 1, substitute and rearrange to get c equals negative 6. So there is our final equation. T equals 2n, take away 6. One final example, 4, 6, 8, 10. Turn that into a table. General equation. Now let's find that difference, and we're adding on 2 each time. So if I did the second term minus the first term, 6 minus 4, that gives me a value of 2. And in my equation, I replace that difference with 2. Then I'm going to find the constant term. So I'm going to take the first values, term is 4, and n is equal to 1, substitute them in, rearrange and solve, and that gives us a constant term of 2. So our final equation is t equals 2n plus 2. Thanks very much for watching.